I have already introduced you to the stdio.h header file, and I showed you that printf and scanf are defined in stdio.h header file. Now, there are other library functions as well. And in this video, we are going to look at some of the functions available in math.h library file. So if you want to use the functions in that library file, make sure you include the header file, which is math.h. And I'm going to show you the functions that are available. So let's Google this, math.h functions in C, and I can take any of these. Let's go for this particular link here. There are several functions available in math.h. One of them is the ceiling function. So the ceiling of 1.6 is 2. The ceiling of 1.2 is 2. The ceiling of negative 2.8 is negative 2. And the ceiling of negative 2.3 is negative 2. And this is how you use the ceiling function. So you write ceil of the value. Then you have the floor function, which rounds the value down to the next nearest decimal. The next function is fabs, which is basically it returns the absolute value of a decimal or of a floating point number. Then you have the logarithmic function. Then you have log to the base 10. You have fmod, which is basically the modulus operator, which works on floating point values. Double is also, it's an extended float. So double occupies 8 bytes of memory, whereas float occupies 4 bytes of memory. We're going to deal with this later. You have the square root function, which computes the square root of a number. And this is the syntax. Then you have the power function, which computes base power the exponent. And this is how you can use it. There are several other ways to use it. And we are going to write an example which describes how to use the power function. Then you have mod f, you have exponential function, you have the cosine, and the cosine inverse or the arc cosine, and you have the hyperbolic functions as well. So let's deal with a couple of functions here. Let's first try to compute result equals to a power b, or base to the power of exponent. And I'm going to show you how you can use the power function. So let's say int base, comma, exponent, and result. Let's say printf, enter base and exponent, scanf, read values into base and exponent, percentile d, comma, ampersand base, comma, ampersand exponent. And then I'm going to say result equals the power function, which is POW. You can always refer to the math.h library file to see how the function is supposed to be written. And it takes 2 parameters. The first one is the base, and the second one is the exponent. You can have any other variable names for base and exponent, but the first parameter here is always the base, and the second is always the exponent. So if base is 5 and exponent is 3, you can compute 5 raised to 3. And if you try to shift the values, let's say exponent was here and base was here, then it's going to do exponent to the power of base. So it is very syntax specific. You need to be careful with that. And as I said, you can always go back here to this particular website, and there are several other websites as well to see how it's going to work. Yeah, so if you read this more carefully here, the C library function double power double x comma double y, which is basically, let's say x and y are integers, they can be floats as well, returns x raised to the power of y, that is x power y. So if you interchange x and y, then you're going to get some other result. So printf percentile d power percentile d is equals to percentile d, comma, base, exponent, and result. Let's run this. Enter base and exponent. Let's say base is 5 and exponent is 3. Therefore, it computes 5 raised to 3 or 125. So 5 power 3 equals to 125. You can try for other values as well. Let's say 16 is the base and exponent is 6. So 16 raised to 6 is 16,777,216.